Okay, this is the team OSU, FABE, SASTRI lab, and we are here today. The first description I will provide is a description of our sensor and its general principle of operation. What we have are, it has been described and has been posted online, is a publication which was in the Journal of Physical Chemistry B, and also a patent. What it consists of is a very simple sensor which has several membranes which allow only a hydrogen ion current, and we basically have an electrode at one end and another electrode at the other end, and we measure the current that is produced as a result. Now, this sensor differs from our previously patented sensor in that we need to allow the flow of seawater to go into the sensor, whereas the other one was a completely enclosed sensor. In order to do so, we have to create openings, and we have done so. However, this is a design compromise because allowing openings means we get a leakage current that can bypass our membranes and give us an error. And so to minimize that error, we've created these so-called tentacles, or basically tubes, that will minimize the amount of leakage current flowing through. So this is a high resistance path, and therefore we should be able to get a reading out of it. So with that being the background description of the sensor, this sensor we will describe separately, all the installation, deployment, data collection, all those in separate videos. But for the moment, just suffice it to say that the sensors that we supply will always be stored under a seawater solution. So they're always to be deployed. Before they are deployed, they're always in storage under a salt solution. Now, here is the main instrumentation pack. This is intended to withstand pressure and depths of immersion at depth. And what this consists of is one set. Here's our battery pack and our instrumentation. Essentially our data logger, which I will open out here just briefly to show you a part of it. Here's the data, the battery, and we will talk in detail about instructions on how to use that. And on the other side, we also have some other instrumentation which consists of a pull this. Okay. It consists of a pressure transducer and thermocouple wires. So we're able to measure thermocouple temperatures within the ocean environment wherein this measurement is being made. And on top of that, we also have another sensor, which we will show you here in a moment. We have our sensor pack is right down here, and our conductivity sensor. We have a conductivity sensor which is also mounted there. And this will be described in a little bit more detail later, but it is installed sort of permanently in this device, and it does not need any further moving. And this entire instrumentation pack, once it's assembled, will be placed underneath this instrumentation package, and then the whole thing will be deployed. And so that's the base description of the system. We will have separate descriptions of the instrumentation download of software, how to deploy the instrumentation and close it up, how to deploy or assemble our sensor, and how to deploy in all the different phases, and in particular for phase 2A where special considerations are required.